All right, so let's get started. Welcome to at Huawei Switzerland, and I will be your host today. Container becomes a buzzword in the community of IT practitioners who strive to transform their organization's IT architecture for better investment to return ratio in the cloud era. So compared to traditional virtualization technologies, container shines in fast and lightweight deployment, lowering the size of application package from gigabytes to megabytes, also reducing the memory usage from gigabytes to megabytes. So in this way, it allows the same hardware to run more applications, result in better resource utilization ratio. So in this session, we will be talking about the evolution of container technology, storage technologies that enable fast and reliable container deployment, typical scenarios, and customer case studies. So please feel free to ask any questions in the chat box throughout this session. I will answer them in the fly and select some of them to be answered at the end of this session by our guest speaker. So please don't hold your curiosity to yourself. Also, there will be a pop-up survey after the session. You are very welcome to make suggestions on what topics you would like to learn about in the future. Any of your comments will help us improve. So thank you in advance. Now, our speaker, Tony Tang, is a chef storage architect and a senior director, having 20 years experiences in managing global research teams and leading the charge of new product development. With special focus and taste on enterprise storage, embedding AI in storage optimization and data management, and big data analytics. So Tony, the mic is yours now.
Oh, thank you. Good afternoon, everyone. My name is Tony Tan. I'm glad to have a webinar with you guys. Okay, just as the host said, Dr. Gu said, feel free to ask any question. It's intended to be a two-way street. So ask your question. I will try to my best to answer at the end of the webinar. Okay. Let me share my screen. All right. So today's webinar has 4 parts. First, I'm gonna talk a little bit about containers development trend, and then later on, I talk about the Huawei's container solution and the typical application scenarios and the successful stories. Okay, container has become one of the very important enterprise technology to implement and facilitate the transformation of the modern enterprise infrastructures. There are about 96 of the enterprise are planned to use or are currently already using the Kubernetes and containers. And the compound rate of containers growing instance has become more than 100%. And we see that, at least from my understanding, there are certain industry pioneer or implement the container faster than other industry, but the containers implementation and adoption has been across the board. Like the internet company and financial industry are the pioneer of using containers. So if you take a look at the containers technology history, it's not too long, but I want to mention to you guys container, the containers technology or the concept can backtrace to the mainframe time. It's similar like a VM. Okay, but container only take off since the Docker's popularity, and then Google donate its own container orchestration platform, become open source project Kubernetes that even drive further of the development of container. And now you can see that pretty much all the companies have certain container technology. Either they want to be a full cloud native application driven for their business needs, or they can they contemplating containerize their business or mission critical applications. So if you take a look at the traditional application deployment, it's more just a bare metal application deployed on a host OS shared by multiple applications, and then on a bare metal hardware. And this approach, everybody knows the drawbacks, right? That's why VMs comes in. The virtualization technology comes in. Right? Virtualization technology did a fairly good job to isolate the different applications and run application on a virtualized hardware. However, VM also has its limitations. First, as Dr. Gu mentioned, the memory usage is at least the gigabytes. You can't create a virtual machine which can do some meaningful work with less than like a 4 GB. And this is the one for the major drawback. You can't really create thousands of VM in one server, and it's gonna be really resource consuming. And in order to start a VM, it's taking minutes if you are lucky. Sometimes it's taking like a 10 to 20 minutes to really fully start the application. And migration capability is also a key problem for VMs. So that's why the container-based deployment comes in. Compared with VM-based, container only need a few a few hundred megabytes of memory consumption, and the application can be started. The container can be started in just seconds. Why? Because they share the same host, same kernel, and the same hardware, only running a container engine on top of that. So the system resource consumption is reduced from VM based from 15% to just 1 to 5%. So its typical use case are for the cloud native applications such as AWS, um, Google and Azure. They pretty much package all their application to container. And now, because of these benefits, more and more applications will be containerized. If you talk about container, you can't uh, you need to talk about the Dockers. Docker really make a container available. Docker is pretty much a container runtime plus some of a bunch of tools to enable the customer or developer to package and build a container image. The container image is similar like a VM image, but it's lightweight. There's no individual OS. It's just some of libraries, right? So this will really help developer to build and package running a single host, Docker, right? However, there's one major thing has not been solved earlier days with Docker. A single node does not have resource to run like thousands of Docker images, right? How to communicate different containers in a distributed cluster? How to support the virtual network of a distributed cluster of Docker's applications? How to schedule it? How to upgrade applications without service disruption? How to monitor of the application deployment, right? All those things has not been covered by the Docker back in the earlier days. That's why the container orchestration system comes in. And currently, the de facto container orchestration system is Kubernetes. Like a couple years ago, there are like a Docker Swamp, something like, and other, Hadoop has one. But however, uh, with the popularity, extreme popularity of Kubernetes become the de facto standard and the foundation of the orchestration system, container orchestration system. If you talk about that, you always associate Kubernetes. The Kubernetes provide the service discovery, load balancing, scheduling, automatic deployment, rollback, etc. Everything all together. And you only need a YAML file. It's kind of file, and issue a kubicato command. You may use that to deploy an application. Very straightforward and easy. And there are many commercial available container orchestration system are based on Kubernetes. So the biggest container orchestration system is Red Hat's OpenShift. Okay. Everybody heard about OpenShift. It pretty much has half of the market share. And then Mirantis use the Docker's orchestration system and Docker Enterprise. And the Mirantis bought the Docker Enterprise and then has their own like Kubernetes orchestration system, but it's all Kubernetes based. And then the next is Rancher, right? And also VMware has its own Tanzu. Tanzu is a bunch of orchestration system bought from the startup, and eventually VMware leveraged that technology, built its own, and now one of the benefits for Tanzu is it can manage the VM and the container in the same vSphere umbrella. Okay. So with more and more ecosystem support, the mainstream enterprise software can deploy in the container. As a matter of fact, pretty much almost all the enterprise software can be deployed in the container environment. For example, like a SQL database, like MySQL, Postgres, you pretty much can install a MySQL in just seconds, just pulling the image from the Docker Hub, and you are good to go. Okay, and there are no SQL database, big data analytic tools like Spark, Hadoop, Elasticsearch, all can be deployed, and also that content management, data processing, machine learning tools. All the machine learning framework like TensorFlow, Cafe can be deployed at the container environment. As a matter of fact, CUDA also can deploy on the container-based environment, and it's really agile and lightweight. Most of the most of the AI machine learning tools are actually running on container. For example, the most popular ChatGPT is actually running deep speed and on top of the container environment. Okay, and HPC, CI/CD, so you name it. And so pretty much 70% of customers are using container in their production environment. And we see that the growth rate of customers' adoption in their production environment has been more than twice, 200%. All right. So historically, when people use container, they use container as a stateless application. What does that mean? So stateless means there's no state to preserve. So you can restart a container without losing anything because container has no state. It's pretty useful for certain cloud native application like a web server or certain kind of billboard, those things. You can restart it. No hard uh, negative effect. However, if you're talking about enterprise adoption, most of them are stateful applications. The stateful application means you have to save, the application has to save client data from the activity and to preserve it across different sessions, right? And for example, database, uh, some like customer service call, uh, data analysis, ERM, CRM, anything to put in straightforward, anything need persistent storage, is a that container app is a stateful app, right? And we see that almost 80% of customer are using or plan using stateful app, right? Stateful app are more prevalent and commonly used in enterprise environment. Okay? So how to support stateful app? That become a challenges. So there is a survey from CNCF. There are four top challenges. One is complexity. Of course, consider it's a new thing and people are ramping up to gain the knowledge. That's why you attend this seminar, webinar too, right? And there are cultural change because continuous development is a little bit different than VM, traditional, typically application. It's a macro kernel, macro based, like a microservice based development. So all different functionality will become a mini service or microservice. It's not like a monolithic application, right? And that's the culture changes. And security is also always be a top challenges for any applications. And stories become the fourth top challenges. So in order how to support the stateful application is very important and critical for enterprise. So how to support that? So people in the early days may choose the local disk because containers running on server, right, or worker nodes, and worker nodes may have some local disk. Then people trying to use the local disk or local storage as to support stateful applications. However, it has major drawback. The first thing is lacking of performance. The local disk, have you ever heard about the slow drive problem? It's killing the local drives, right? The local servers, because the slow drive always be an issue. Server is meant to handle compute task. It's not meant to handle this large, massive storage request. So local disk cannot handle the high performance requirement from the applications. That's the first thing. Second thing is the reliability. Local disk is lacking of all those enterprise features a dedicated storage system can offer, like snapshot, replication, and active, you name it, right? So all those things means reliability, high availability. So which is like a worker nodes or a single server cannot handle. And also this resource with the resource, because in order to maintain certain level of redundancy, it need multiple copies. But in the dedicated storage system, it has erasure coding, etc. Right? So that's the left hand side of the local storage. So quickly, the container application which require higher reliability, performance, sharing, are choosing dedicated storage, and they may use their they may already have this infrastructure like fiber channel storage network. They can leverage that in the same way as the VM in the container environment. So that's why if we talk about the stateful application, most of the serious customer are choosing dedicated storage. So people also talk about SDS. So what SDS is a bunch of software running on commodity hardware, uh, compose a global storage pool from the local disk, and to provide the certain kind of uh, storage system services to container. It's like a Ceph or Portworx, right, or Gluster. So compare with real serious enterprise storage, like from Huawei, from NetApp, from Dell EMC, the SDS has some of a problem. Um, One of the major problem is similar like a local storage is a per performance, especially per NAS performance, right? And also reliability less than the significantly less than the enterprise storage, and also has a lot of OM issues. Why? It's not because SDS the concept is wrong. It's because that most of SDS or software defined storage are coming from startup. Startup only have how many engineers? Like 10, 100 at the most, right? And they need to deliver first a workable storage system, and then they they can have time to develop certain features like snapshot or something, right? But comparing the enterprise storage system, it has been there for more than 20 years, right? And there are thousands of engineers who developing those features. It need time. So that's why SDS is lacking serious enterprise features like clone as um, remote replications, like a active high end features like a like a DDU compression, etc. You name it, it's taking there forever to develop that. Um, so that's why, again, if you are serious enterprise customer are developing mission critical or enterprise applications, you need to seriously choose the enterprise storage system. Right? So how to support the container uh, from the enterprise storage system? Yes, there are two ways, right? Sun and NAS. So Sun is suitable for database, and the NAS is support all those unstructured applications. So the database include a SQL database, non-SQL database like a MySQL, Postgres, uh, and MongoDB, etc. Sun is very suitable storage for them because it's high performance, stable, low latency. And Sun has been supporting database for quite long, and it has a lot of accumulate experience and features and performance needs to meet the needs of applications like database applications. But for other applications like data analysis, CI/CD, HPC, machine learning, content management, data processing, you can choose NAS. Why is that? Right. So because only NAS in container system can support sharing across different pods. Okay, so if you design your application architecture require a sharing among different applications or same application, different instance, uh, then you need to choose NAS storage system for container storage. So Sun, by design, cannot be shared across multiple container applications or instance. It's not a drawback of a storage system. It is designed by the CSI's uh, uh, protocol. So if you're using the continuous um, storage protocol or interface called CSI, you have a drawback of sun cannot be shared among different instances, but the NAS can. So that's why NAS is very popular choice for continuous storage. Okay. All right, I just talked about the Sun provide a higher reliable, powerful data platform for database containers. So here are some features like supported by Sun, right? One feature is called read write once, which means that only one container instance can read and write that volume. Okay, so read write method is not supported. Again, it's because of the CSI limitation, not because the enterprise storage limitation. Whenever you choose Huawei storage or Dell EMCs, it nobody can support read write many because the protocol limited that. Okay, so QoS, snapshot, clone is all capacity extension is all supported. So most of the features are supported. I'm gonna talk a little bit more on the CSI later on. Okay. Sun support more scenario because it enable the sharing across different applications or same application, different pods or different instance. Okay. So how to support container storage? So container Kubernetes design a protocol called CSI, Container Storage Interface. Okay. So previously, you don't have to remember is they are using in-trade volume plugin, and it really has a lot of drawback. And then they move to flex volume, similar thing. Now the mainstream is CSI. Okay, it's a if you want consider this similarity, you may think it's a open source WASA provider. Okay, in the VM environment. So everybody, like every vendor, develop a WASA provider for VMware, right? So similar things. Everyone develop a CSI plugin for their storage system, but this CSI is open source. Everyone, everyone has that open source CSI driver published in the GitHub. So if you search the Huawei CSI, you immediately it will direct you to the GitHub Huawei CSI driver. If you go to Dell, you go to like a NetApp, it all has their open source CSI driver. You can build the CSI driver on your own, a particular vendor. If you want to try Huawei CSI, you can use the pre-build from the GitHub, download it from there, or you can build it on yourself, customize it. You can change even the code to see what happened. So it's all open source, right? And so this CSI is a consortium. Every vendor agreed a certain interface, and every vendor follow that, right? Design their own plugin. With their plugin, Kubernetes can really provision the storage or volumes automatically without human intervention, right? So if you want to create a volume from inside Kubernetes, they call the PVC or PV, persistent volume claim or persistent volume. Kubernetes can create right away for you and attach the volume to a particular pod, or you can consider a application instance, a containerized instance, right? And then you're good to go, right? And it's automatically done. It's similar like a WhatsApp provider. It's no human or the administrator involved. And here are those features supported by CSI, like create PVC. It's like create a volume or create a line in the storage system. Delete PVC, create pod, delete pod, resizing, right? So it supports offline resizing, online resizing. From now, from here to all the way end, those are the features are recommended support by the CSI driver. So the vendor are not obligated to support those features. So, for example, you may find out that a certain vendor does not support online resize, which means online shrink the file system, online shrink the volume, but it does support offline resize, right? And even the CSI supported, a particular vendor source system may not. So you need to be careful to take a look at the vendor's compatibility list. See, oh, if this particular functionality is supported by the particular vendor, okay? Just to point out, Huawei support all those, right? So, and there are volume restore, clone, topology, etc. All those features. And one more things, I happen to be in the board of CSI. I want to mention to you guys is because this is the multi-vendor consortium, the create new features or new interface is extremely lengthy process, and therefore it create a challenge of create more support uh, through the standard CSI interface. For example, if customer want, oh, how can I use Kata, right, uh, to support a stateful application in container or Kubernetes environment? Well, you're out of luck if you're using CSI standard CSI driver, because look at here, the current interface has no support of Kata. So there may be different implementation. There may vendor may not support it. So I'm gonna talk a little bit more about how Huawei can support it in the similar way using CSI, right? But CSI, the consortium is still uh, discussing how to support the Kata because every vendor has their own opinion. So it's hard to make agreement among different vendors, right? All right. That's the thing, right? So compare with the regular support, like just create a manual, create a volume, and you ask the storage administrator, talk to the container or Kubernetes administrator to manually attach the volume to the pods. It's gonna taking forever, right? Especially if application has 1,000 or thousands of instances and thousands of volumes, right? It's gonna be taking hours or maybe days to configure that, right? That's why CSI automate this, right? Similar like a WhatsApp provider. If you can manually create that, but it's gonna be really hard for you to support a VM, right? And I will now dive into detail. Similar concept, automatically be done by the Kubernetes if you vendor provide a CSI provider driver. Sorry. All right, so we talk about standard container development trend. Let's talk about the Huawei's container solution. So Huawei's storage container storage solution has been there for almost 5 years, and we support all the mainstream uh, container orchestration platform like Rancher, OpenShift, Vanilla, Kubernetes platform, Tanzu, and we also support the other flavors too. And the people and customer can feel rest, that most of the Kubernetes orchestration platform are supported, and all the applications, as long as they using standard container packaging, are all supported by our storage solution, container storage solution. Not only we support the standard CSI, we actually using CSI driver plugin to support some extended feature too, which are not all the vendors support that, like QoS, multi-tenancy. It's all through the similar standard way of CS driver, and developer can support that, right? Can use that, no problem. And also we have industries um, pioneered called CDR. What is that? It's a uh, data recovery or disaster recovery solution uh, with integrate with the container platform. And if you talk about DR, right? So every storage vendor has a certain DR or replication or backup uh, uh, solutions. However, they only take care of storage side. The CDR not only take care of storage side, it take care of application side. It will back up and replicate the application, the whole application, means the application itself and the data to a secondary storage system. And once disaster happens, it will automatically automate the application restore and start up. Everything is automatically be done, not only in storage side, but together with the application. So for example, if you have a MySQL application, right, and if you're using CDR, CDR will backup, ultimately backup your application MySQL's data as well as your application's um, itself, configuration, etc., everything to storage side. And then once if you want to restore to another cluster or even a public cloud, you can replay it, do a restart quickly. It will automatically restart on a different data center or different cluster. Okay, you do not have to restore the storage first and then restart or reconfigure the application. It's all done together. Okay, and underneath we have our Ocean Store Dorado, which is a converged storage system support NAS and Sun all together to support the containers environment. Okay. All right. I talk about the CDR plugin, very unique, right? And you can back up all the application, uh, pods, data, everything to the storage system. It's automatically be done. You only need a uh, specify the schedule using a standard Kubernetes way, and then it start backup, right? And when you do a recover, it can using a snapshot to recover your data quickly, right? And all your application automatically be recovered too, okay? And it also can leverage the hypermetro hyper replication, and to replicate to another storage system. And if the one side has a disaster, it can automatically restore all the applications, pods, and storage system. If you only have one pod or one container instance, it's maybe okay to manually do it. But consider if your production environment has thousands of pods, it's gonna take days for manually to recover the systems. But CDR only take minutes to restart the pods and restart the applications, connect all the volumes automatically. You don't have to do any single things. It's all automated. Okay. So therefore, it really can uh, uh, realize the RPU and RTU very less RPU and zero RTU and RPU. Okay. All right. As I mentioned before, not all the storage features are available through CSI, but Huawei has a very smart way to support those features through the same interface and as a CSI, and user does not have to change the way they deploy the containers, deploy their applications. At the same times, they can use the extended features like QoS, multi-tenancy, right? And content, sorry. And how can the Huawei storage can do that? So we deploy our Huawei's CSI, and this is a standard way of a bunch of hyper containers, uh, public available to help the Kubernetes provision and using the external storage system, and and we actually expose all the interface through standard CSV YAML files or like a JSON file, so that the Kubernetes can use that the same format to use the Kata, multi-tenancy, and QoS, which are previously not supported by CSI. Okay, I'm going to talk a little bit more in the following slides. You have a visual understanding of the how it can be supported. Okay. All right. So one of the benefits of using the enterprise storage system to support container is you can take a snapshot instead of a hard copy for uh, reliability, okay, or redundancy. So Huawei supports the standard snapshot, but our snapshot is role-based. Role-based snapshot is so-called read-write technology. A lot of storage vendor has this call base, which is copy-write with older technology. Compared with the older COW, role-based snapshot has a lot of advantage. It can create a snapshot in seconds, so which means your RPO only be limited to a couple seconds, and it virtually can take as many as you want, like thousands of snapshots without any performance penalties. And it's easy to manage. Automatically, I manage it by CSI driver and through the interface. And you can delete a snapshot and without performance impact. Okay, so those are the benefits. Pretty much every vendor support snapshot, but our snapshot is role based, has a lot of advantage. Okay. All right. How to support end-to-end QoS? The similar way as the how the customer deploy their containerized applications. So we using the same concept of storage class. It's which from the Kubernetes. If you're familiar with Kubernetes, right? So this is a typical YAML file from Kubernetes storage class definition. You just need to add a vendor specific field like QoS. This is not from the standard Kubernetes storage class, but it's understood by Huawei's storage class. Therefore, Huawei storage CSI driver will try to configure the QoS, and QoS will be supported, right? So with the QoS, you can really specify a particular port, right? The maximum bandwidth, the upper bound or lower bounds of the performance need requirements, and the storage system. Huawei storage system will try to honor this requirement and limit or allocate the resource to support that QoS. Okay, it's very important, especially for financial field, because you want give your mission critical application more bandwidth or higher QoS than the some of the lower priority applications, right? And the storage system will allocate the resource and keep that application bandwidth as required. Okay, so this is QoS support. Same way as you deploy standard storage class. Just add a few line of code, it will be done. Okay. All right. Similar like QoS multi-tenant, you only need a modified storage class, and you're done for the tenants. The Kubernetes standard certain multi-tenancy concept called a namespace. Each namespace is kind of like a tenant. However, it does not support a finer granularity in the storage level. So, which means that you cannot demand a particular storage volume. It need only consume certain storage, right? So, how to support that? You need storage multi-tenancy. The storage multi-tenancy work with the Kubernetes multi-tenancy altogether. They can implement a full end-to-end multi-tenancy solutions. And we have a complete solution paper talk about how you're going to configure the multi-tenancy in the Kubernetes environment. Okay. Kata. So that's another feature is lacking in the Kubernetes. Kubernetes does has Kata, but its majority is limited compute resource, how such as CPU, memory. So storage Kata is designed to limit the certain parts of PVC or container application for the storage usage. Okay, similar way as before, like when you use Kata in the VM or bare metal environment, you can use the similar way, but you config as the way normally Kubernetes use, like using a YAML file with the storage class. All right. So everyone has NAS, right? Why Huawei's NAS has a better advantage compared with other vendors, right? Huawei's NAS performance are much faster, higher than any other vendors. And our CSI driver, the performance of also higher than other vendors too. So what that means? If you configure one volume, right? For example, if a container application require a persistent volume, and the Kubernetes will try to call CS driver, a vendor CS driver to provision a volume. For one volume provision, it may not make a whole lot of difference, right? Everybody take a similar time, so user may not notice. But if you configure 1,000 of volume, you want to be them finish in minutes, right, or seconds. You don't want like taking like 10 minutes or even 20 minutes to finish that. However, the CS driver does has a performance limitation. Not every vendor CS driver are created equally. Huawei's driver can create much faster, provision volume much faster than other vendors. Why we can measure that? Because we download, every vendor's CSI driver, we provision that, we test it against our Huawei CSI driver, we are 30% faster. So it's critical for large-scale container deployment. If you have thousands of persistent volume, it's gonna take a lot of time to provision those volumes. But Huawei's driver are much faster. Okay. So as I mentioned, the slides, we all performance are head-to-head better than any other vendors. I will now dive into detail. One of the unique thing about Huawei CSI is our support of NOF. Okay, not vendor support, not all the vendors support that. So CSI driver, typical vendor support Sun, right, and NAS, right? In some, they support maybe fiber channel or iSCSI, right? That's typical way of support sun storage system, and it's okay, right? But Huawei storage driver, CS driver, not only support fiber channel and iSCSI, we support NOF, NVMe over Fabric, including NVMe over Rocky, NVMe over fiber channel. So that's much faster technology than fiber channel alone and iSCSI. Okay, you can see the difference. The latency is much smaller than the fiber channel, and the throughput are much higher. Right? I won't dive into detail. You can Google everyone else like a website is a NOF is the way to go. However, not vendors support that in the container environment. You have to be carefully look at the vendor's compatibility list published from their CS driver in the GitHub. You download from the GitHub and check the compatibility list. Okay. All right. So in a typical scenario, failover scenario, how storage system can facilitate the failover. So this is like a typical case of a pod failed. If a pod failed, because the storage system are enabled shared across multiple pods, the other pods can um, the pod can migrate to or reschedule to another worker nodes and by Kubernetes automatically, and it can access same storage automatically. Okay, no administration involved. And if a storage node fail, right, and the pod can automatically access another storage system transparently, because we support active-active, and without manual failover, uh, the user can or pods can automatically access. This is vendor specific, okay? Not all the vendors support that, okay? But if Huawei support that through standard CSR, no user intervention, okay? And that's a case of a particular disk or drive fail, and is automatically uh, handled by storage system internally. Uh, pod did not even notice that, okay? Not dive into detail. Ransomware attack also happens in the container. I see a lot of customers are actually combine the ransomware attack with their container environment. Just want to mention that we have the industry leading 4-level of protection on the ransomware. All right, typical application scenarios. Because of time limitation, I'm gonna briefly dive into that. There are typical how to use the CSI, right? How to use the container storage system. A very useful application is CI/CD environment. We have a complete storage, NAS storage solution to support the containers CI/CD scenario. So every application for related to CI/CD like GitHub, GitLab, uh, Jenkins, image release tools, image repository from container, Kubernetes using NAS storage are shared. And once code commit to GitHub, it normally pushed to the storage system, and Jenkins will or CI server will read it, build the container image, package it, send it to CD server, and CD server will publish to the Kubernetes mirrored repository. So it's also automatically done. Everything accessed through a single NAS storage system, reduce the storage silo, improve the TCO, higher availability sharing. So typical scenario. Another scenario is leverage NAS container storage elasticity, right? Why people choosing container is because of elasticity, right? And most of the applications require like an online capacity expansion through container CSI and higher performance scalability. support from one single container image instance to thousands of instances, like cloud bursting environment. So those applications like live stream, AI, web service, large scale for financial service, video, etc., all need NAS container storage elasticity. So you need, when you choose the storage system, you need to make sure that that storage system has a superb elasticity, right? It can support not only one container instance, but thousands, and can do the online expansion without performance issues, right? All those things need to be supported. So be careful to choose the storage system. All right. Another typical use case is a Sun container storage to support the database, distributed core database. As a matter of fact, in China, most of the big banks are already containerized their core business distributed database, or they are in process of containerize their distributed database applications to Kubernetes or container platform. This is the perfect use case of using high performance the NOF plus high performance the storage system to support this use case. Okay. Successful storage. Huawei storage container solution has been supported customer for many years, and as a matter of fact, I personally support a lot from Latin American, Europe, China, everywhere globally. And one for example is a top international bank is building their storage resource pool with a Huawei CSI, Huawei storage container solution. So they using two Huawei storage high-end storage system to build a replication using our CDR. Remember the replication automated by this Huawei CSI extension CDR, and they are able to support all kinds of application like monitoring, AI analysis, pipeline, log system, and they are able to achieve 6 nines reliability. And they also eliminate the certain performance bottleneck from those container applications, right? So, for example, their AI analysis can finish much faster than before, right? Using the Huawei storage container storage solution. They also can do the scale out and the capacity extension online without service disruption, and all the systems are shared, all those data in a single unified storage system. Okay. Second use case, a Fortune Global 500 bank using Huawei container solution, NAS solution, to build their container application environment. They are using OpenShift. It's supported by Huawei, and previously using NetApp's storage solution. They need to do the manually switch over for the replication, but with Huawei, it's automatically using Hypermetro is actually accurate. You don't need a manual switch over; it's automatically be done, and the switch over fail over time is done in 14 seconds. That's the time take to spin up a container. Okay, so the storage system is always online both sides, so there's no failover. Okay, it's just need the container just started, need startup time. But compared with the before, like NetApp product, they have to do a manually switch over because they do not support active accurate. Okay, from that NAS, and also the performance are much higher, reduced from 10 milliseconds to just 1 milliseconds. Okay. All right. The last, customer successful story is a top bank in China. Actually, I personally know that bank, and support that project. They're using our Huawei CS driver to build a DR solution and across multiple data center, and they are able to automate the DR recovery using our CDR. And in other field and other side, there's no customer involvement. All the application can automatically recover from the another center. And of course, the performance are much higher and easy to share. And the TCO can reduce to 30% compared with the previous uh, solution. So that's pretty much it.